Okay. So in the second module, the second bit is a wear. So wear and friction, we already know that they are the part of the tribology. So where there is a friction, there is a wear, and it causes the mechanical failure. And for that, we have to go with either lubrication or any type of a bearing or a bearing material. This is what the solution. Then what is meant by bearing? Sorry, wear. So what is meant by wear? So wear, yes, yes, it is a loss of. It's a periodic loss of. It is a periodic loss of material with the action of two surfaces with relative, yes, with the relative motion only it will cause the a periodic loss of material. So wear can defined as it is an undesirable. It is a desirable or undesirable? It is an undesirable a removal of a solid. Solid means it's a substance. Okay, solid from a sliding or a rolling component, either in the sliding or rolling. We already know that the friction may be a sliding friction or rolling friction. Okay, if there is a friction, it will cause the wear. So this wear is an undesirable removal of a component or substance, either maybe in the sliding or rolling. This is what the wear, or wear we can also define as it is a periodic loss of material with the action of two materials when they are in the contact. If the two materials are in contact, there is a periodic loss of material will takes place. That is also we can call it as a wear. Take an example of board and choppies. If I keep on writing the on the board, what happens? The choppies will start wear off. Correct? So it is a periodic loss. If I increase the speed, what happens? The wear rate is increases. If I decrease the speed, wear rate is decreases. Yes, it is with respect to the time period. It is a periodic loss of material. If the time goes on, it will increase the wear. Is it correct? So it is called as a wear. And we already know that the wear is because of a friction. It is purely because of friction. If there is a friction, there is a wear. If there is no friction, there is no wear. That is what we already discussed in our earlier class. So it's already mentioned, and this wear is an one constituent of, it's a failure of any material. Okay, and this wear can be defined as it is a progressive. Progressive means the wear rate keep on increasing. Okay, it's not a constant, it is a progressive. Okay, it's a progressive a loss of substance. Progressive loss of substance. If you go with the time and wear, if the time increases, the wear rate is also increases. It's keep on progressing. So it's a progressive loss of substance from the operating surface. Where? From the operating surface of a body occurring as a result of relative motion in the surfaces. Where it is only the wear takes place where the two surfaces are contact and there is a operating surface. It is called as a operating surface. Okay, operating surface alli the wear will start and it is progressive. And this is a slow. Of course, a wear is a slow. It won't sudden. Is it a slow? Wear is a slow process. It may take 1 year, 2 year, 3 year, 4 years, not one day, 2 day. Okay, it is a slow process but continuous. It is a slow and continuous process of removal of material from the one or more element, maybe one element or one or more element. And this it is like a just friction, but it is not a intrinsic property. It is an external characteristics of the body. Here wear is not an intrinsic property. Wear is purely a external property. What is meant by intrinsic property? What are the intrinsic property of material? Hmm? Intrinsic property of the materials are elasticity, plasticity, isotropic. Okay, so stress, strain, these are all intrinsic property of the material. But this wear, it is not like intrinsic, it is an eccentric, means it is an external property of the material. Clear? Wear, it's an just like a friction, it's an external property of a material which depends on, this wear is directly depends on what are the parameters. The wear is directly depends on the parameters like load, speed, temperature, hardness, surface finish, and presence of foreign materials, environmental conditions. So these are all parameters which contributing to the wear. Okay, if these parameters, they are in the direct contact with the wear, if the load increases, what happens? Wear increases. Okay, if the speed increases, obviously wear is also increases. If the temperature increases, if these parameters like load, speed, temperature, hardness, if the surface is very hard, what happens? Yes, it will, yes, it will scratches the another surface and start wear of the another material. Okay, so board and choppies, which one is harder? Board is harder, so that choppies will start wear off. If it is reverse, what happens? Board will start wear off. Okay, so which one is harder? It will wear off the another material. Okay, next, surface finish. Can you agree? If the surface finish is more waviness, what happens? More wear. If it is a smooth and fine finish, what happens? Wear reduces. This is what we discussed in our earlier chapter, surface engineering. Okay, we discussed what happens if the surface finish is the roughness. Okay, it's smooth, so it will directly contribute to the wear properties. And presence of foreign materials means, if the lubricant having an contamination or any dust particles, those particles directly deals with the wear. Okay, it will affect the wear. If more foreign particles or dust particles or contamination in the lubricant, it will wear off the either any one smooth material. Okay, in the two surfaces, either any one is a smooth, one is a hard and other one is a smooth, so in that smooth material will start wear off. Okay, and also environmental conditions like moisture. Okay, if the moisture is more, what happens? It will start producing the corrosion or rust on the surfaces, and it will produce the wear. Or if it is a chemically reactive, if it is a chemically it is not a stable surface, what happens? If condition is chemically reactive, again it will form the chemical reactions and it will produce the byproduct, and that byproduct will affect the wear. Clear? So these parameters directly affects the wear and increase the wear. Clear? Okay, like speed, temperature, load are the major affecting parameters. And in some of the cases, permanent changes occurs. In the some of the cases, what happens if the more wear takes place, and it will causes the permanent changes in the component. If the permanent change in the component, and what happens directly, it will failure in the ultimate of the equipment or devices. The failure or what happens, it may takes the any damage in the component. Okay, this way may cause permanent change in the component. And these we can analyze with the help of Debray's equations that we will discuss in the next class. Okay, delamination and Debray's analysis. And come to the wear analysis, how we are going to analyze the wear. Okay, just like a postmortem. So if any death is occurs, it's a unnatural death, what the police will do? They will take the death body into the hospital, and next step is go for the postmortem. So from the postmortem, what you will get? You will get the exact reason for the death. Correct? Similarly, in our mechanical component, after the failure, we have to go for the analysis. Means what cause will failure will contributing to the failure of that component. Okay, that is what the analysis. And here also same thing, we have to go for the wear analysis. And the first analysis is analyzing the wear problem in a machine. It means in every machine component there is a wear, that because of a vibration. Correct? Take an example of fan, a simple fan, that fan, okay, or any your lathe machines, or any complicated bike design, or car, or aircraft, ship. So in every mechanism or every component, there is a vibration. That vibration will cause the wear or friction. Okay. So here it is in the analysis of wear problem in a machine. It is necessary to determine the kind of wear that occurs. There are so many types of wear. Okay. First, we have to see the failure component, and we have to analyze which type of wear occurs. Which type of wear occurs. Okay. There are abrasive wear, adhesive wear, erosion wear, corrosion wear, pre wear, critic wear. There are so many types of wear. So which wear will contributing to the failure of the component? First, we have to analyze. Clear? First analyze, we have to see which type of wear takes place in the failure of component. The failure component. Next, analysis requires a microscopic examination. Microscopic examination of all areas and close look at the used lubricant. And with the help of microscope, we have to see which type of failure takes place, whether the surface is very smooth surface or rough surface, that you have to see, and which type of lubricant they are used. The lubricant is also contributing to the failure of component. Why? The lubricant may have the contamination, that may have the dust particles, or that lubricant itself a very chemically reactive, correct, or it may having some water particles that may leads to the moisture, that may cause the corrosion. So these are all problem with the lubricant, that also you have to consider for analysis. Clear? And wear is generally proportional to the, that is what just only discussed, wear is proportional to, directly proportional to the load and the amount of sliding. If the more load, what happens? More wear is there and causes the failure. If amount of sliding means contact area, if more the contact area, more the sliding, what happens? Wear also more. So in the choppies and board, there is a one point contact. So what happens? Only on that point there is a wear takes place. If entire choppies contact with the board, what happens? That entire length of the choppies will start wear out. Okay, that is what the sliding contact. Clear? So these what we have to analyze. These are the steps we have to analyze the failure of the component just due to because of the weight. And during the process of wear in this system, there may be a one or more possibilities. Okay, the first possibility, transfer of materials from one element to another element. There is the one possibility, the transfer of element means there are two surfaces, one surface is hard and other surface is soft. So transfer of element from the soft to hard, okay, takes place, and there may be a welding takes place, and that welding projection will start flowing the another smooth surface. That is also a type of wear. That is transfer of material from one element to another element. It's a one case. Second case, materials lost from the element 1 to element 3. That is what element 3 means. It's the lubricant or any foreign particles between the two surfaces. Surface 1, surface 2. Between that, there is another element called lubricant. Lubricant may have contamination of dust particles. That is what the element. There is a because of element 1 and element 3 or element 1 and 2. There may be a chances. And formation of reaction products. Like it may be chemically reactive. Okay, that surfaces. That chemically reactive produces the byproducts because of chemical reaction, and those byproducts may cause the wear. Clear? These are the possibilities. These are the possibilities of wear. Wear means not only a one surface to another surface. It may be a one element to second element, or one element to third element, or maybe second element to third element, or maybe any chemically reaction. Clear? Will causes the wear. And this is what the microscopic analysis see. This is a body 1, body 2 because of the load and because of the motion. When it is relatively moving with each other and having a load, so it causes. This is for the surface. And here you can see surface 1. Here it is look like a very straight surface. But if you see in the microscope, you can analyze that there is a projection, there is a waviness in the surface. Clear? So this is the one. U means velocity, W means load acting. Okay, and because of this, there is a direct contact. There is a contact between these two surfaces. Okay, or there is a third element which is present between these two surfaces, and these may causes the wave. And here if you don't use any lubricant, okay, because lack of the lubricant, if the varies occurs, lack of lubricant, if varies occurs, then that is called dry wave. It is called dry wave. Okay, so your bike, what happens if you continuously use, so engine oil in every 4 to 5 kilometers, 5,000 kilometers, you are changing your engine oil, correct? If you won't change, what happens? Simple live example, it will cease. There is a ceasing between your engine. It is because of if you won't use the lubricant properly, means the entire lubricant will dry off. Because of continuous use, the lubricant will dry off, and finally there is a direct metal to metal contact, and that metal to metal contact will cease. Cease agutane. So ಕೇಳಿದ್ರೆ use ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ, so that mechanic will say, sir, your engine is cease off. It is because of lack of lubricant. That type of wear is called as dry wear. Okay, and now come to the types of wear. So these are the so many types of wear, and here these are the contributing. So these are the contribution of wear in percentage. Okay, so which type of wear is more causes the failure? Okay, these are the types. First is adhesive wear, next abrasive wear, erosion wear, polishing, contact, fatigue, corrosion wear. Okay, next electrocorrosive, fatigue wear, electric discharge, cavitation damage, false drilling. So these are the different types of wear occurs, but in that there are important types. Are first one is abrasive wear. So in the 100% failure of wear, in out of 100%, a 50% contribution is 50% contribution is abrasive wear. If 100 components are failure, okay, in that 50 components is failure because of abrasive wear. Because of abrasive wear, the 50 components failure means the percentage is 50%. Clear? Next is adhesive wear. Adhesive wear percentage is, when compared to the abrasive, it is less. It is only 15 percentage. Next type of wear is fritting. It is of 8%. Next erosion wear 8%, and chemically reaction wear is 5%. And the rest, it may be a corrosion wear, cavitation, and electric discharge. So these are all 1 or 2 percentage. It's a very rare case. Clear? So these are the types of wear and the contribution of wear percentage. So we will discuss one by one. First type of wear is called as adhesive wear. So what is meant by adhesive wear? What is meant by adhesion? Have you heard the word adhesion? I think in the derivation, in the assumptions, we made up one assumption. In the Reynolds equation, or maybe in the Eigen-Poiseuille law, or in the parallel plates, we made one assumption. What is that assumption? There is a perfect adhesion between the surfaces. It may be a surface 1 with a lubricant, perfect adhesion, or lubricant and the another surface, what? A stationary surface. There are two surfaces. One is stationary surface and another one is moving surface. In between those two, there is a lubricant, and there is a perfect adhesion between those surfaces with lubricant. That is what the assumption we made in our derivation. Okay. So adhesion means a bonding between one layer to the another layer. So here the adhesive wear means because of this adhesion action, because of this adhesive action, a one surface. See, here there are two surfaces. This is a surface 1, surface 2, and these two surfaces are moving. Relatively, they are moving with each other. Okay, then only wear will takes place. And this surface, there may be a small projection in the surfaces. It may be a waviness or in the projection, and these two surfaces start bonding with each other. These two surfaces are bonding with each other. Okay, the removal of material due to the adhesive between the two surfaces. Adhesion means there is a bonding takes place. So adhesion means if you want to paste one paper to the another paper, what you will do? Huh? You are using gum. Okay, you are using gum. With the help of gum, you are going to paste the one paper over another paper. Okay, that is what adhesion. So here also same thing. One surface over another surface, there is a adhesion takes place. Okay, if adhesion takes place, what happens? It will restrict to the movement. It will restrict to the movement. Is it correct? If there is adhesion takes place, what happens? It will restriction to the movement. And if we apply the force, what happens? Any one of the smooth surface will damage. That adhesion is temporary. It is not permanent. Okay. And if the load increases or speed increases, what happens? Any one of that surface may get fractured. It is called cold weld. Means the projection of the two surfaces. Because of adhesion means a cold welding. Welding means joining it to metals. Correct? Welding means joining it to similar or dissimilar metal with the help of electrode. Okay, or filler material. Here what happens? Here there is no filler material. Okay, there is no any other material, but because of adhesive nature, any one surface start bonding with another surface. This is okay. Slip gauge, you can take example, there is adhesion between the two surfaces. Okay, so that it will restrict the movement. Okay, here also same thing, there is an adhesion takes place between the two surfaces, and if we apply the force still more, what happens? Any one surface get fractured. So this type of wear we can call it as an adhesive wear. Okay, here there are two types. One is a mild adhesion and severe adhesion. So mild adhesion is the removal of surface film or oxide layers or lubricant layers. So that is the adhesion between the lubricant layers and the material is called as a mild adhesion. If the severe means it's a more dangerous. Okay, it's a removal of material due to the tearing, breaking. Okay, that will takes place. Here it's such an example of a severe adhesion. Okay, and this is a one microstructure. Through the microstructure we can see the surface how it is tear off. See here. Okay, and for this we are using one equation. This equation is W, which is equal to wear rate. W means wear rate, which is equal to K P by H. Okay, K is the coefficient of wear and P is the that is what the load which is applied on the material. Okay, because load is directly contributing. If the more load, there is a more adhesion takes place. Okay, see here, if the more wear means a more coefficient as well as more load. Okay, and H means it is a thickness. And this is what how we are going to prevent the adhesive wear. So these are the method. Through these methods we can prevent, we cannot eliminate, but we can prevent the adhesive wear. There are two ways, one is mechanical and other one is by using the lubricant. So mechanically means how we can prevent. Mechanically means how we can prevent this adhesive wear in general. If the more load, I told more load. See this equation. P means load applied. Okay. If the load increases, wear is rate also increases. So reduce the load. If you reduce the load, it will reduce the adhesive wear. And also by reducing the speed and temperature. The one method is either by reducing the load, speed and temperature. These are the parameters. If you reduce, what happens? Wear also reduces. This is what mechanical way of solution. Okay. Next is improving oil cooling. So that oil cooling means whatever the oil we are using for lubricant, that lubricant we have to cool. We have to use some cooling agents or some cooling methods to reduce the temperature of that oil. Okay. If the temperature reduces, means that the oil temperature reduces means indirectly it will increase the viscosity. If the temperature increases, what happens? Viscosity decreases. That is what we discussed in our first chapter. Viscosity is a function of temperature and pressure. If the temperature increases, viscosity decreases. Okay. So if more viscosity is there, it will avoid the contact. Okay. And use the compactable metals. Okay. Next, apply surface coatings. Yes, that is what we did in our last class. There are so many methods for surface finish. A coating is a one example. With the help of that coating, we can reduce the friction as well as wear. This is what mechanical way. But in the lubricant, if we go with lubricant, use more viscosity oil, more grade of oil. If you use, it will avoid the wear. Yeah, which type of wear? Adhesive wear. Okay, and also use extreme pressures. That is what we already know, that viscosity is a function of temperature and pressure. If the temperature increases, viscosity decreases. But if the pressure increases, viscosity increases. Okay. If you use more pressure, viscosity obviously increases and it avoids the contact. If contact avoids, friction reduce. Friction reduce means weight decreases. Okay. And this is done by with the help of additives. We can use additives in the lubricant. By adding these additives, we can increase the viscosity and pressure. Clear? This is what the mechanical way and lubricating way to reduce or friction or prevent the adhesive wear. Clear? Okay. So next type of wear is abrasive wear. So I have heard that abrasive action. I think you already know this. Yes? Grinding. The best example is grinding. So in the grinding operation, what happens? The abrasive wheel or abrasive tool. That is what the cutting tool is. Abrasive wheel. The abrasive wheel moving on the metal, that will wear off. Correct? That will wear off. Here what happens? See, the soft and hard surface. Here there is no adhesion. Here there is no adhesion. But instead of adhesion, the two metals, okay, two surfaces. One is moving surface or stationary surface, whatever it may be. But there are two surfaces. Okay. In that, one surface is soft and other one is hard surface. Okay. Soft surface and hard surface. So what happens if they are in contact? Means the hard surface start wear of the soft surface. That is what is taking place in the grinding. Grinding is the best example of abrasive wear. Okay, grinding is the best example of abrasive wear. So here there is a abrasive action. Abrasive action will take place, and the cutting, okay, means that hard particles, cutting of ferrous means flowing. It is called as flowing. Flowing, have you know the word? Flowing means, flowing means that the projection will start make the scratches. Okay, scratches on the another surface. The best example in agricultural flowing the same things happens here. Okay, so one is a soft surface and other one is a hard surface, and the soft surface starts flow of the hard surface. Okay, or else any contamination in the lubricant, the hard particles scratches the soft particles. Okay, it is 2 body and this is 3 body. In the abrasive, there are 2 types. One is 2 body means 2 surfaces. Any one is hard. It is 2 body. But here, if any foreign particles, it's the hard particles, it will make the scratches means it is called 3 body abrasive wear. See here, 3 body abrasive wear. Surface 1, surface 2, and it's the hard particles maybe from the lubricant or maybe from the outside. Okay, it will damage the surface. This is can call it as a 3 body wear and 2 body abrasive wear. Abrasive wear means it's abrasive action between the hard surface ore and soft surface. It takes place the material. Okay, it is called as abrasive wear. And this is what microscopic examination of this abrasive wear. And abrasive wear can prevent by mechanically and by lubricant. So remove abrasive by providing air, oil, filtering, okay, cleaning, means that 3 body abrasive wear there is a contamination. That contamination with the help of cleaning we can remove that particle. Okay, if you remove that, it will avoid the 3 body abrasive wear. Okay. Next, minimize the shoot means if any particles moving speedily on the surfaces, okay, it damages the surface, that we can avoid. Okay, and increase hardness of the metal. And the third thing is we can automatically increase the hardness of those 2 particles, 2 surfaces. It will reduce the weight. That is done by with the help of surface coating. Okay, and lubricant use of oil free of abrasive particles. That is what filtering, or directly you can use free of abrasive particles. That oil if you use, and use more viscous oil. More viscous means if the viscosity is more, those oils we have to use. So these two are the way of reducing the abrasive wear, between 2 surfaces. Clear? So adhesive wear and abrasive wear. Adhesive wear means because of the one surface bonding over another surface, that is called adhesive wear. Abrasive wear means the one surface is hard and other surface is soft. There is a wear takes place, means hard surface flow of the soft surface, or else if any third particles contamination is present between 2, it is called 3 body and 2 body abrasive wears. And these we can reduce by with help of mechanical way or lubrication way to reduce or prevent the adhesive or abrasive wear. Clear? So in the examination definitely you are going to get a question. So briefly explain the abrasive wear mechanism or adhesive wear mechanism. With the help of these figures you have to explain.